Ideal gas equation, already I proved now. What is ideal gas equation? PV is equals to nRT, where n is number of moles of gas, where R is universal gas constant. Its value, I tell you in the later class, it comes out to be 8.31 joule per mole per Kelvin. Its value we can find out practically, that I'll tell you in the later class. So this is the relation which connects between pressure, volume, temperature for a given mass of gas. This will be constant. So this is very good equation. If you know any two variables like volume and temperature, if you know, you can find pressure. If you know PV, you can find temperature. This tells the relation between pressure, volume, temperature. So this is very useful in some circumstances. Okay, so for example, you may have, suppose you have got here one air is trapped in the, let me take, this is the lake, this is water here, this is water here. Here one air bubble is trapped here. Suppose its temperature at this time is T1 and the volume here of this is V1, and due to the weight of liquid here and due to even atmospheric pressure, the pressure here of this trapped gas, let me call V1, as this bubble goes up, then as it comes, it may increase its volume, volume will change, and here it is only under the influence of atmospheric pressure and even the temperature changes. Then you can, if suppose two variables are like P1, T1 are given, and even here pressure whatever is P2, here when it comes volume is V2. If suppose, if you know variable, one of the unknown variable, you can find it. This is where this equation will come into play. If two of the physical quantity you know, then third can, and it's under these circumstances, what is the volume once it comes up, the rest of the things given, then this bubble goes up, what is the volume once it comes there, we can find using this relation. So many applications are there, and one more important thing, this equation will be applicable only for ideal gas. Okay, what is ideal gas? The gas in which intermolecular forces are neglected. We consider no force of attraction or repulsion between the molecules. Okay, so it is a hypothetical gas. Regarding more and more ideal gas, we learn it in kinetic theory of gases. As of now, you keep it in mind. It is hypothetical gas in which molecule to molecule attraction or repulsion is not exist. Size of the molecule is negligible in comparison with volume in which the gas is trapped. Okay, this equation, whichever gas obeys, that gas is also called ideal gas. So this gas will hold good for real gas provided for low pressure and high temperature. So real gas is very nearly, it will act like a ideal gas. This is the perfect gas equation. Okay, thank you. One of you asked P1 V1 equals to P2 V2, how? Okay, suppose this is one cylinder here, this is one piston. Here suppose one gas is trapped here, assume the temperature is constant. You are not changing the temperature of this gas. Okay, suppose pressure here is 1, volume here you can say 2. What is P1 V1 here? 2 into 1, it will be 2. Okay, now anyhow, if suppose temperature is not changing, then suppose if you lift it, this piston up, suppose this comes here, the volume now here to here increases, As volume increased, let me say volume now in final. Suppose if it is becoming 2, pressure will drop. The molecules have got sufficient space, then they'll not hit interior with very high impacts. The molecules will not create more force, more hitting. The impact is not there. If volume is more, then the molecules have got more space. They'll not hit with high impact on the interior of the vessel. So pressure decreases. Initial pressure we have taken 1. So here, okay, let me take volume more. Volume more, we have increased the volume more. Let me take the volume will be 3. The pressure will be such that what is P2 V2? Here what is P1 V1 will be 2. The result definitely will come 2. So as to have 2, the automatic pressure and volume they adjust their value. As volume increases, pressure will decrease in such a way that we have 2, some fraction value you have to take here. So what should be, let me take here V2 as 3, and what should be P2 has been taken. So that result must be 2. Let me take, this is what, can I take this 1 by 1.5? Okay, just 1 by 1.5, 1.5, then result will come 2. No, what is here in initial case result is 2. Final case, if volume increases, pressure will become 1 by 1.5. Automatically pressure decreases, but their product never change. Product will remain the same, provided if this gas is ideal gas, provided you're not changing the mass of gas, provided you're not changing the temperature of the gas. So product of P and B will remain constant. So whatever the state of gas, you increase volume, decrease volume, but PV will be a single valued as long as the temperature and mass of gas you are keeping constant. So Boyle's law. Pressure is inversely, you can take a vice versa. Volume is inversely proportional to pressure, keeping here temperature constant. What is its meaning? Okay, definitely, suppose if you have, this is one container, here we have got some gas. Okay, now suppose if you increase pressure inside it, let me suppose, okay, let me take, this is balloon. When you decrease the volume, this is balloon. When you decrease the volume, okay, then the molecules will start to hit with high force. When you decrease the volume of this balloon, slowly when you decrease the volume of balloon, then the force with which molecules hits the interior of the balloon will become more and more. For example, if suppose this duster, this marker has fallen from 0, when I keep my hand here, it will hit with less velocity. When I keep my hand here, its velocity increases. By the time it comes, it will hit with high velocity. When I cut this motion of marker here itself, it will hit with less velocity. When I make my hand, when I allow it to fall from height, it will increase its speed, it will hit with high speed, and it will create more impacts. Likewise, When you decrease the volume, then you're cutting the speed of molecule at smaller vicinity. When you decrease the volume, then the speed with which molecules are hitting becomes more, and the impact on the balloon will be more, pressure will be more. Suddenly, any gas, if you bring it close suddenly, if you decrease the volume, then automatically its collision becomes more, and they create more force on the periphery of the container. Then they create more pressure. So, as long as we decrease volume, pressure will increase. As we increase the volume, pressure will decrease. So many such cases we can have in practical life. Okay, that is there. So wherever provided temperature must be same. ನೀವು ವಾಲ್ಯೂಮ್ ಡಿಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ ಆ ಸ್ಪೀಡಿಗೆ ಕಟ್ ಮಾಡಿದಾಗ ಆ ಸ್ಪೀಡ್ ಹೈ ಸ್ಪೀಡ್ ನಿಂದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಹಿಟ್ ಮಾಡ್ತಾವೆ ಇಂಟೀರಿಯರ್ಗೆ. ಹಾಗಾಗಿ ಏನಾಗ ಫೋರ್ಸ್ ಕ್ರಿಯೇಟೆಡ್ ಆನ್ ದಿ ಇಂಟೀರಿಯರ್ ಹೆಚ್ಚಿಗೆ ಆಗ್ತದೆ, ಪ್ರೆಷರ್ ಹೆಚ್ಚಿಗೆ ಆಗ್ತದೆ. ಹಾಗಾಗಿ ವಾಲ್ಯೂಮ್ ಕಮ್ಮಿ ಆದಾಗ ಪ್ರೆಷರ್ ಹೆಚ್ಚಿಗೆ ಆಗ್ತದೆ. ಒಂದು ಮಾತ್ರ ಟೆಂಪರೇಚರ್ ಅನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಕೋಬೇಕು, ಗ್ಯಾಸ್ ಅಂತೂ ಚೇಂಜ್ ಮಾಡಬಹುದು. ಇಫ್ n moles are there, n moles have to keep constant. Right?